Okay, good day. This is dual enrollment pre-calculus. I am Mr. McCulley, and this is lesson number 25, verifying trigonometric identities. So let's get to it. We have one goal. We're going to verify trigonometric identities, and verifying trigonometric identities is kind of like proofs from geometry, except when we do our verification, all we're going to do is um, go through the steps. We're not going to justify all of those steps, but we're going to, but as just as a rule of thumb, to get the full credit, you're only going to do one step transformations, and each of these one step transformations have to be something that I, as your instructor, could see from one of these fundamental identities. And so I know that's a little bit difficult right here, but um, as we go through it, you're going to see what I mean. You have to do these one step transformations. Now, there are some general rules. There's no hard, fast, like please excuse my dear Aunt Sally order of operations for identifying or verifying trigonometric identities. And we also have to accept the fact that there's probably more than one way to do it. And so um, your answer may not look like my answer, and you could still get full credit. So keep that in mind when you're doing this. But our guidelines are going to work with one side at a time. You're going to try the most complex side first, especially if one of the sides has just one term and the other side has like pluses or minuses in it. If it's got or multiple fractions in it, it's much easier to condense two fractions than it is to expand a single term. And that goes right into the second one. We're going to try and factor things or try and add and subtract fractions. So if you can factor something out, like a greatest common factor, excuse me, you'll do that, or try and add and subtract fractions if you can. Try and use the fundamental identities when possible, and you kind of have to. Everything has to be a one-step fundamental identity. Convert all to terms of sine and cosine, and those are fundamental identities. They're either the reciprocal identities or the quotient identities. You can use those to convert to sine and cosine. And then just try something. If you try something and get into a dead end, it may give you some insight into where you need to go to get to the correct answer. So let's just look at a couple of these and see what I mean by one-step fundamental identity transformations here. So we're asked to verify this trigonometric identity. And so for this basically says any value that you pick for y, if you plug it into this expression on the left-hand side, you're going to get 1. And so we need to show that. And so since I got to decide where I'm going to go with this, since I have cotangent squared and secant squared, in my mind, I'm thinking the Pythagorean identities here. So I come over here and I see a secant squared and I see a cotangent squared, and cotangent squared has cosecant in it. And here, if I bring this one over, I get secant squared theta minus 1 equal to tangent squared theta. Now that is a good move for a step. And the reason why is we're taking something that's two terms and changing it into one term. So secant squared y minus 1 can be transformed, cotangent squared y, into just tangent squared y. And so now I've taken two terms and condensed it into one term. Now I still have these two values here, and I need to make them equal to 1. And I look at my reciprocal identities, and I see that cotangent theta is equal to 1 over tangent theta. So I can do that one-step transformation, make that 1 over tangent squared y, and leave this tangent squared y. And now we can multiply, because fractions, you just multiply numerators and you multiply denominators. So I'll have tangent squared y over tangent squared y. And clearly that's 1. And so all of these step transformations are required for the correct answer in this particular problem. And again, I'm sure there are other ways. This is just the shortest way that I thought I could see it. Another type of problem they'll ask you to do, and in the book I know that this one says graph these two equations, put 1 in y1 and then 1 in y2, and then look at the graph to show that they're equal first, and then they want you to do it algebraically. That's all we're going to do here. And so I'm just going to set them equal to each other and say this is cosecant x minus 1 over 1 minus sine x is equal to cosecant x. And let's see here, what are we going to do first? Well, let's change everything on the left as terms of sine and cosine. So I have 1 over sine x, and all I'm doing is using a reciprocal identity, minus 1 all over 1 minus sine x. Okay, still trying to get that equal to those two equal to each other, or equal to cosecant. Let's see if we can't, and here I'm going to say recall that a minus b times a plus b is equal to a squared minus b squared. So I'm going to multiply this numerator by 1 plus sine x. I'm going to multiply the denominator by 1 plus sine x. And the reason I'm going to do that is because in the Pythagorean identities, if I go 1 minus sine x, if I bring that over, again, I can condense that into a single term. And again, we're trying to get down to a single term. And so that might be helpful. So in the denominator, just using the difference of squares property, I can say that that's 1 minus sine squared x. That should be a sine. Now I got to distribute. So 1 times 1 over sine x is 1 over sine x. 1 times negative 1 is negative 1. Sine x times 1 over sine x is sine x times 1 over sine x. And I may have to erase here and extend this fraction bar a little bit. And then finally, sine x times negative 1 is negative sine x. All right, and so this shouldn't be a multiply here. Sorry, it should be a plus. Because when you distribute, you have all pluses. Now, the good news is sine x over sine x, those cancel and becomes 1. And so just to keep it as a one step, I get sine x, 1 over sine x minus 1 plus 1 minus sine x all over 1 minus sine x, sine squared x, excuse me. And so my 1's cancel. Set that equal. And let's simplify. I get 1 over sine x minus sine x all over 1 minus sine squared x. And I guess I want to combine a fraction again. Make this into a single term and see what we can get rid of. So to do that, I'm going to multiply this one by sine x over sine x. That'll give me 1 minus sine squared x over sine x all over 1 minus sine squared x. Okay, so before I move on, just as a quick recall, because I got this big fraction over value, if I have a over b divided by c over d, remember when you divide fractions, you multiply by the reciprocal. So a over b times d over c. So I'm going to put this over 1, and since I'm multiplying fractions, we're going to do the reciprocal. And so I'll have 1 minus sine squared x over sine x times 1 over 1 minus sine squared x. Now, at this point, we've done a couple steps. Remember the goal. We're trying to get cosecant squared. And remember, just cosecant. Cosecant x is equal to 1 over sine x. Well, the good news is these two cancel, leaving me with 1 over sine x, which is cosecant x. So we did a lot of things there, and there are a number of steps, but all of those, at least in this particular proof, are required for us to get the correct answer. All right, last one here. Verify the identity. I picked this one because it has a little bit different stuff than what we've seen so far. And it looks really difficult at the beginning, but after we get to do it, it's fairly straightforward and fairly simple. I don't see anything that I can combine, but I can find the GCF of the left side. So we're going to do that. So pause here and take a second to think, what is the greatest common factor of both sides? Just real quick pause. All right. Hopefully you all came to the same conclusion, and the greatest common factor of this term and this term is secant to the fourth x times secant x secant x tangent x. Now, when I divide secant to the fourth x, secant x, tangent x out of this term right here, I get secant squared x. When I divide secant to the fourth x times secant x tangent x out of this term, I'm dividing the whole thing away, so that's just minus 1. All right. So how does that get me closer to there? It gets me a lot closer, because I know that secant squared x minus 1 from my trig identity cheat sheets is tangent squared x. Secant to the fourth x, secant x, tangent squared x. And now it's just a multiplication. Secant to the fourth x times secant x is secant to the fifth x. Tangent x times tangent squared x is tangent to the third x. These two cannot be combined, so we are left with what they are asking us to do. And really, it's this whole expression is our answer. Well, that's all I got today. So the Star Wars fun fact of the day: Steven Spielberg's creation, E.T. the Extraterrestrial, a great 80s movie if you've never seen it, makes a special cameo in the Senate scene from The Phantom Menace. And so you can see right there a couple of E.T.s. That's all I got for today, folks. Have a good one. Bye.